So, I wanted to start with a few words from, paraphrased from a behavioral scientist whose name is Jordan Peterson. I don't know if you know his work. He's Canadian. And some of his thoughts about writing were very inspiring. And I didn't think about this, but, when we consider and when we reflect and when we muse, let our thoughts wander aimlessly, there are things happening. There are muscles that are moving. There's blood flow changes and heart rate changes, and there's signals that are being sent throughout your whole body. And that's an activity. And I didn't consider that picking up a pencil and putting my thoughts down was part of that. But apparently in behavioral science, they consider the act of writing to be manifest thinking. So that when Jordan said that learning how to write is learning how to think, it really struck a chord with me. And I was somebody who didn't get very much schooling, so I taught myself how to write and went to people who were willing to correct or to help me with logic, with organization, with note-taking, with planning, with self-reflection. And all of these things, I think, helped me to re-elaborate things that have happened to me and to draw lessons from them for what I would like to have happen. So, I also think that, and this is kind of ironic that there's so few people to come to this topic, because I think that this is actually the fundamental aspect of the Access Syllabus, which is critical thought and manifest thought and different ways in which we communicate. Because communication isn't only the unrecorded word, it's also what we document and what we project, right? What we imagine in a manifest form that other people can look at and comment on or enhance, right? And we inspire each other that way. And then that, goes into practice. It inspires and informs the practice, and then the practice is the basis for further discourse and reconsideration, etc. And it's this cycle. So, the Access Syllabus is a list. Actually, it's the consolidated list that comes out of all of this consideration. It comes out of thinking, considering what has happened, what people have done, and what they do, and what we would like to do. So this is actually what the first notation system looked like. That was the very first version. And it was born at the same moment as the Access Syllabus. That was what I brought with me the first time I taught a class that I called the Access Syllabus. It was a group of ballet students. And they looked at me as if I had suddenly sprouted antenna. But somehow I knew that I was onto something. And as you can see here, this is now what it's going towards in the right-hand corner. It's going towards a symbological map of the body, and going towards the use of the various parts of that map to start to be able to describe events, processes, and compare events. And it goes along with a device for mapping space. And descriptions of complicated processes of movement. So, for example, these symbols represent undulatory introductions of kinetic energy into the spine that then result in a form or a shape of the spine, which can be transitory. Okay, so just briefly show you the latest tutorial, just to show you what subjects in movement have been considered. And I won't go into detail about most of these things, but just because I noticed that one of the first questions that I get is, well, have you thought about this? And have you thought about that? And have you thought about time? And have you thought about, etc., etc. So I wanted to allay your fears. That I wanted to make sure you're not concerned that I haven't considered things, and just go through these different aspects. Okay, so one of the fundamentals of this is a biomechanical basis. So that the orientation is towards the construction and current evolutionary status of the human body as a basis for beginning to talk about what it can do, or what it does, what it can do, what it did. So it's not an aesthetic orientation, or we hope it's not. I mean, that's something that we have to constantly work to get away from, right? Or work to notice that that's there, and then somehow get an alternative point of view about what we like, what we don't like, and why we don't like or like something. Okay, so using the symbols in this language to describe movement depends on your interest in the structure and function of the human body. Right? If you're not willing to study anatomy, and if you're not willing to embody the understandings that you get from anatomy, then this system will punish you, because it will make you work harder to describe what you'd like to describe. Let me explain that. There are default symbols which are very simple that describe complex movements.
What is a default symbol?
A default is like the basic operating system of a computer is a default system.
Okay.
If you want to change that system, you have to go into the parameters, and and it takes a lot. It's very time consuming to do that. So you can describe any kind of movement with this system, but it's faster, it's easier to describe movement that is in accord with the support of the health of the human body. Yeah, so it rewards you for creating, inventing, working with descriptions of the human body in it that support its thriving, right? And it punishes you for doing the opposite. Punish. I mean, it's just more labor intensive. Okay, so here's an overview of different conventions, different symbol conventions for how you could break the body map apart into its various pieces, and then how you could turn them or organize them to already give an indication of what that body part was doing when you started to describe the event. Yeah? So the notion of the event is something that begins and goes on, so it's not a moment. Yeah? This is another aspect, which is that there is a way to describe status, in other words, a still moment in this system, but it's assumed that you're describing process. Like a note, right? When you sing, you go la. It's not, when you write music, and you see the note, there's a time duration. So that's a process. And music is very efficient for describing time. Yeah, this notation. So this is also what I attempted to do, was to describe time. Not a status. Usually when people make up their notation system for movement, they draw a little stick figure. Yeah. And this is supposed to represent a moment in a sequence. But this system is describing a process as part of a sequence. Okay. So hold your questions. Let me just go through this. Make a note of it. All right. So these are explanations of the different symbols, and I think symbology is really important. So, for example, the egg shape. The egg shape has historical significance. The triangle is meaningful. The star is meaningful, right? What is particular about different parts of the body? For example, the hand that has the opposable thumb, or the foot that has the bridged arch and the toes. What's peculiar about the scapula is its right triangle and the acromion, this kind of shelf that sticks out. So, like taking a look at architecture and symbology through history, and seeing the significance that has been drawn actually from the shapes of the human body and what they communicate, what they imply. As a kind of, the same thing has been done with languages, right? The letters, the breakdown of the letters, they're like the runes, the ancient Celtic runes, that in the beginning these symbols were considered magical. In some cultures they still are. And I really think that language actually is magical, because it can redefine reality. And in that sense, it's also very dangerous. Dangerous in a good way. Okay, so here's just a little bit of the notion of space. So the basic is the Cartesian coordinates, the planes and axes, and that's been mutated into a clock system with these different planes, interrelated planes, a kind of matrix of circles. And here you can see the way the numbers would be allocated then as destinations. And here we come to another point that's different maybe about this system, is that the default is that you write from your own point of view, not from the point of view of a spectator. So you don't place the body in an external spatial grid. And I think that step of evaluating someone else moving, rather than writing about the experience of moving, is one step towards aesthetic. Like the arrangement of the body in space as you perceive it is already an interpretation, right? An outward interpretation. So this is one of the choices. And then you could write in the beginning, this is from the spectator view. Right? You could change the point of view. Okay, so This is an overview of the variations for movement. Right? These are symbols that describe the different vectors that you would take. The numbers represent the hours on the clock. Here's an explanation, right, of how the different numbers on the clock represent the different diagonal vectors. Okay, so we have that, and we have spin, and I'll go over that later. Different kinds of spin and directions. These are combinations of spin and vectors. These gray arrows are orbits, right? So curved trajectories, which you can combine with vectors and spin to get helixes and spirals and so on. So this is a way of describing complex movement. Here's how to construct a partition. This is some examples of using these body parts as symbols to give you a location for an event, right? And adding arrows, different kinds of arrows, to indicate direction and rotation, etc. So, for example, this is the pelvis, right? And this arrow represents a clockwise horizontal plane spin. So in that case, my pelvis would be going. And these symbols are very powerful because they imply the use of the rest of the body in a certain manner. And if you've sublimated the understanding of anatomy and biomechanics, then you know what that implies. And this is maybe an interesting example. This is the pelvis, of course, and that's the right leg, right? The upper leg. And this spin arrow is going through the thigh. Yeah. So what that's telling me is that my pelvis is actually going backwards, while my knee is going forwards, which would be something like this. Right? That would be a central flexion of the hip. And I don't have, you know what I mean? Like, once again, you can see the value. Because if I have to write, my pelvis is retracting and I'm doing a central flexion of my hip while my knee is advancing, you can already see like the amount of words that you need to describe that action. It's already huge. Yeah, what we're trying to do is get away from this, the problem with Laban, which is taking 6 hours to notate 2 minutes. Which is what I've been told. The experts say that. So then there's the joints, right? The articular centers. So the way you start describing events would be also then in what's considered in the Access Syllabus administrative areas, right? We're thinking about the body parts as having mass and moving, creating kinetic energy. Then these areas are what regulates them. Yeah. Ways of, just so maybe you're interested in why these dots. Right here, that represents a circumduction. Circumduction is a continuous biaxial motion. So you can understand maybe intuitively that represents an arm with a hand. That's my right arm and hand. Yeah. And this spin arrow is indicating the horizontal axis. And so this is the movement. Yeah. Where this is a hand, my right hand. That's a vector arrow and the circumduction, and the gray arrow is an orbit arrow. So what's happening there? The vector is up, the gray arrow is over right, which means, right? And the circumduction So then there's support, right? Different areas that we use for support. And the support is classed into areas that are cushioned and areas that are bony, right? The different things we can use them for. And then there's nooks and crannies, right? Little inny places where we can dock, grapple, and load, right? So docking zones. And all of these, the circles, when you move them around, they become indicators for location, right? And also indicators for use. So if you put a circle here, then that's going to mean that's a support area. Put a circle here, that's going to mean that's a docking area. So you already have an idea of what's going on. Right, and I used this system for describing the degree of support. So if the circle is empty and it's in a support area, then it's touching, but it's not weighted. If it's striped just one way, then it's partially weighted, which means that I would have weight on something else, right? It implies shared weight. If it's filled in or crosshatched, then it's the only thing I'm using for support, right? It has full weight. And it could be shaded in different ways. Right? So I could also indicate the direction that I'm coming into that support area, or how I started, or what amount of that support area is being used. Okay, right, and there's the notion of open chain, closed chain, right? If I draw a body part and there's no support indicated, then it's not touching the ground or a sort of support surface, it's not grappled, so it's an open chain. So if I were to draw an arm, then it would be an arm in the air, yeah? Or an arm that's not being used for any one of these things. But as soon as I indicate a support area, it's touching something, whatever it is, right? And then you can get specific about that. Yeah, and this is a discussion of composite posture. In other words, when you get closer to the floor and when you get further away, there are different options for how you organize. And this is a discussion of families of organization, right? There's things we do that are very similar in certain circumstances, and what we've done is to group them. Yeah, so it's like a scale. You can say, I'm working in this scale, which is a certain postural value, which has a family of options.
A certain amount of kinetic energy, of potential.
Not necessarily.
Potential.
Oh yes, you mean like the distance from the support surface, but you could also be leaning away from something, and that's yeah. It's not necessarily a description of kinetic potential, but yes. Yeah, because kinetic potential is also inherent in movement, right? So it's not just a static potential. Okay, so these are more complicated little shapes, and maybe they're too complicated. I'm still working on, but maybe you get an idea of how you can take these symbols and you can put them together and they become new symbols. Yeah, so actually there's only 7 different kinds of line in the symbol system, and they get put together in different ways to create meaning. And that was also one of my interests, right? Was to keep reducing. And every time I get together and collaborate with people on this, I find another simpler solution. So this is also my interest in sharing it with you, is to get help.
So it already gives us to 7 types of lines?
7 types of geometry.
Yes, 7 types of geometry.
Ah, okay.
And also my interest was to make it so that it's easy. So you don't have to have a lot of graphic skill. You just have to be able to write in an orderly fashion. Like, you wouldn't have to know perspective, or be able to draw life true proportions and so on. Yeah, want to get away from that so that it's easy to communicate. Yeah, and here's an example which I think is really convincing. So this implies full support, right, on the right leg. And the support area is the anterior calf. So that means I'm balancing on my anterior calf. And now the number 4 implies that I'm in that family of relationships, sphere 4, which means that my knee is slightly extended, my hip slightly extended or extended somewhat, right? And that would be like this. That would be that moment. So by just writing these three things in a number, I've given myself a clue as to what the rest of the body might be doing. Because I know I can't balance on that area without waving my arms around, without being slightly pitched forward. Exactly, without not having my spine organized a certain way. So, these are all implied. And then I don't have to write that out. The 2 lines indicate whether it's almost bent all the way, right? Like if I'm here, almost sitting down on my heel, right? Or midway, right? Or up on my feet, or fully extended, so that I have different ways of describing that family. And this is the grapple point, right? So when I put a 5 here, that indicates that I'm grappling something, right? That I'm using that area for support. So then my body must be, head down, right? Or I'm leaning into something, So I'm already closing the possibilities on what I could be doing. Okay. And you can see and here are muscular contractions. Yeah. So you can get an idea just from the kind of contraction what you would be doing, right? Because when a muscle's changing length, then whether it's getting shorter or getting longer, you already have an idea of what the body's doing, right? Whether the joints are going to flexion or extension, etc. When it's isotonic, then you know that there's an external force, and so you can get an idea there's already something going on with support, or an object that the person's holding, or an interrelationship with another person. If it's a co-contraction, then you know that the person themselves is using a muscle set on both sides of the joint to stop movement. Eccentric, right, would mean that the muscle's lengthening, concentric, etc. Okay. Symmetry. And this is maybe a kind of poorly understood subject in the Access syllabus because we sometimes say that mostly what we do when we get around is asymmetrical in nature. But that's not considering repetition through time or reflective repetition through time. So if I do this and then do that, the actions are reflectively symmetrical. Yeah? And especially if I do this and then do it again, every time I do it is a repetition. So then through time it expresses itself symmetrically. So there's various kinds of symmetry. For example, this process and then the same process in reverse, right? That's reverse symmetry. And when I use these devices, I can describe what's going on one side and then use an indicator to say that the same process is going on the other side in reverse, or at the same time, or later. Right? And that's another way of speeding up the notation process, right? Because then I don't have to make a separate symbol set or separate description for the other side. Yeah, and this is the jewel of the human movement alphabet, is descriptions in the spine. And I think these symbols are particularly powerful because what happens in the spine is extremely complex. And if you were to take all this time to describe it, then you need a book for just one movement. So I think these descriptions are really helpful. Sometimes when I'm watching movement, I'll just write down what happened in the spine. And just by looking at it later, I can guess the rest. So I can almost notate movement sometimes at the same speed as it's happening, which is, I think, really, really useful. I'm sitting in a train, on my way to a workshop, and I'm coming from another workshop and just had time to pack my bags, and I don't have time to get into a studio, rent a studio to work out the next phrase. I can sit on the train and make up the next movement. Here's an example of a phrase, a series of movements. And you can see how you can stack them so that the circle then becomes the beginning of the event, right? And this event goes on until the next circle, and how they could be closer together, so that would mean almost feathering, or at the same time, or and just from looking at that, you can already have an idea. Oh, that's a spine, that's a hand, that's a foot. Yeah, already have an idea, an intuitive idea of what's happening. And this is also, I think, the power of symbology. That when the symbols are cogent, when we can reference them easily, then they'll have more impact. They'll be more useful. And this is something that I think makes it difficult for me to work with Laban. Even though I've looked at it, I don't know, it's not intuitive enough. It's pretty. I like the way it looks. But it's hard for me to grasp. All right, so these are descriptions of, very complicated movements. It's an alternative to using like a composite of vectors and orbit arrows and so on. You could use these along with one vector arrow and indicate the direction of the spiral, right, or the helix. I love this one in particular. That's one of my favorite symbols. I think it's extremely useful. That's the recoil property of elastic tissues. So, for example, I could notate extension and then flexion with a rotation and put elastic recoil in there, right? And it becomes this. So it's extremely useful symbol. This is a series of arm movements, all working with elastic recoil. So you see the arrows, they're vectors, yeah? And it means that the whole, in this case, when you write out the arm from the shoulder to the hand, that means that the whole arm is involved in that recoil process. Yeah? So also how much of the body you draw implies how much is involved in that movement. This just an example of how you can combine undulation with the vector. Yeah? And this I think is really interesting because you don't have to write a body part. You could write a direction and give it to your dancer, or your student, and just say, do what you think this means. Work it out. And that becomes a creative score then for discovering your own movement ideas. Right? It gives you a limitation, and I think the score idea is really interesting. You could do that with the body parts too. Just write, hand, pelvis, shoulder, etc., and give that to your dancer, or have them write their own and trade, and they come up with interesting things. And here, timing, accent, transition, duration, degree. And I don't know if you noticed, but this is the play symbol, from the old video or cassette player. No? This is the pause symbol, which I've repurposed to mean suspension. And of course, this is the full stop. This is the symbol you can use to describe status. Yeah, when you created a shape, and that shape is lasting. And then I've readapted the musical system to use these bars, or even the clef, to describe the length of time. And that's also interesting to use. Some of the video cutting symbols. Yeah, and this is very useful to bracket these things, and so that section gets repeated, and then you can use the symmetry symbols to indicate whether it was repeated on the other side or repeated in reverse. Yeah, and I do have symbols for forces, surfaces, partnered situations. Not in this tutorial. Let's see. I have just enough time to share this tutorial with you, I think. So this is the latest mutation of the kinesphere idea. And I'm still toying with it, so I'm really interested in your feedback. But one of the things that I noticed was that I have a space that's like a small space that I can work with, right in the middle of a sphere. Of a kinesphere, and then a sort of middle area, like 15 degrees deviation, and then a peripheral edge, right? So I wanted to find a way to notate that. And this has been my recent project, which is to try to develop a system to be able to give myself destinations on those different areas. Okay, so here's the idea about 3 layers, and my terminology is exokinesphere. Exokinesphere would be this peripheral area. So anterior frontal plane, posterior frontal plane, superior, inferior, transverse, and the parasagittal planes. And then endokinesphere would be the planes that bisect me, right? So the median, the caudal, and the the coronal. So here's just a look at the way I would divide them into 3. This means that, that you would have, what is it, 36 destinations for each plane. Yeah, so you'd have, if you're thinking about these things as clocks, right? So 12, 6, 12, 6, 12, 6, 3, 3, 3, 3, 9, 9, 9, etc. Yeah, and I think that gives a bit more intricate mapping of space than other systems that I've seen. And there's always this idea of a clock, right? It's just a smaller clock or a bigger clock. And it's a clock in front of you, a clock in back of you, side, up, down, or inside you. I'm talking at the same time, so is it hard to look? No. No. Okay. Fun with pages. No, this is Keynote actually. It's actually quite fun. There's a lot of options. Okay. Okay, so here's the 36 destination clock face, right? So this is the coronal plane, and already introducing an idea of motion, and taken from the Mariners. They talk about roll, which is frontal plane motion, and pitch, which is sagittal plane motion, and then yaw, which is transverse plane motion. So my head is yawing, or pitching, right, or rolling. I think that's also an interesting example of how, like in the history of the gathering of terms in the Axis syllabus, how that's been such a inclusive thing. How we look at different disciplines and find references that make sense for describing what's going on when we move. Okay, so then we take these caudal planes. We take these endosphere planes and clone them. So in other words, the numbers are always in the same spot, right? They're cloned, so that the one above me still has the 12 in front, yeah, and the 6 in back of me. The sagittal one, right, clone, still has 12 o'clock here, 3 o'clock there, 6 o'clock. It's not mine.
It's not mine.
Yeah, and here's just a very quick overview. If you just put one arrow, then it's an indication of a movement towards the exact center of a plane. Right, so if I just put that, then it's right towards the center of the parasagittal right plane. There's a version of this on YouTube, but it's not the latest one. And I'm going to have to give you my newest version, Ula.
Yes, I only have the
Ula recently interviewed me about the system, and it was then published on i.de, this website. So here's how you put the numbers at the tip of the arrow, and that would then give you the oblique destination, right, in any one of these clocks.
And to this you would sound like a part of a body symbol, so which part is moving that way? Or?
Exactly. You say which part is moving that way, or you could just put the arrow and let somebody work it out.
Yeah.
They could choose the body part. So that leaves space for creativity. Okay, so here's how I indicate the endosphere, which is with 2 arrows coming out of the circle. This is with the dot in the middle would be the middle circle, right? The one that's not so large. And then just the dot and the arrows is the small circle, right? The inner circle. Now the exosphere arrows actually they bump into the circle that they're pointing at. Or if it's just a dot that they're pointing at, then that becomes the inner circle. Right? So with the open circle and the arrow, it's the middle circle. And then the dot is the inner one. These are summaries for you. It's a repeat, right, actually. If you've grasped the idea, we don't have to go through them all. But I think this helps to have a repetition of the notion. So all the options on the sagittal planes. We can watch one more. And then I want to show you how you could. Oh yeah, actually, I'd like to get past this just to look at spin. Okay. Let me go past that. So let's see. This is it's the right-hand thumb rule. So let's see. If you see an arrow, for example, this arrow pointing up, and you stick your thumb in the direction of the arrow, and you close your fingers, and that gives you the spin direction.
It's the same physics.
Yes, it's kind of repurposed. It's not exactly, but yes, yeah. So you get the vectorial spin. And that's another example of how we've repurposed these ideas. So this, for example, is right, all these spins, and of course the circle is just generic. You can put a body part there, so you can say that that part of you is spinning. And then we have orbits. So this, the idea about an orbit is that it implies a number of different forces, right, that are acting on the body part. And it's another way, when you draw a curved arrow, it's another way of implying a lot that's happening, right, that you don't have to write. Yeah, so this is an example of a score. So this would be like a directional score that you would give to someone to work out. Yeah, and they would work out which body part was moving where. Go ahead. Yeah, go ahead and write it down, and or use it and make up a sequence. We have a little space back there. We can move the couch. If you have questions about what's happening, shall we go through them? Okay. So this is the inferior vector, right? So that arrow is pointing straight down towards the center of the inferior transverse plane, right? At your feet. That gray arrow is a spin arrow, right? So that's a horizontal counterclockwise spin. That's a vector arrow towards the middle circle, the parasagittal middle circle. So that's somewhere here, not here and not here, right? So in other words, something that's spinning and going towards the middle. Yeah? For example, this is an overcurve towards the left. Right? An orbit towards the left. It's a roll movement. That's another spin arrow, so you tell me which direction is it spinning. Clockwise. Not clockwise, transverse. And this is another vector arrow that's pointing again to the parasagittal plane. This is a orbit, so it's going from inferior to superior over left. And this is a vector arrow.
What does that vector do there?
Sorry?
What does that vector do there?
That vector is the same one actually as this kind. It's pointing at the center of whatever plane. Right? So this is the superior transverse. So that means that arcing movement is going towards the center of that plane. You don't understand?
No, the last one. What did you just...
Okay, so
the arc moving is going towards...
So the center of the superior transverse is right here.
Yeah.
So whatever arcing movement I'm doing is going. It would have to be orienting towards that point.
Towards that point.
Yeah.
Okay.
As opposed to orienting. It could be orienting towards one of the clock destinations.
How do you know about where the middle rings on the stays?
Well, if you have an arrow that's pointing down, that's the inferior. You take this. I went a bit too fast for you. Sorry. So, but if you take this Cartesian grid as the key, and you put the arrows, that would be forward. Yeah, because it's from my perspective. So this arrow means straight ahead. Yeah? And this arrow means straight back. According to my perspective, straight back. And this one, straight side. And this one, other side. This one, straight down. Okay? This one, straight up. And then I use the numbers to give myself obliques. Yeah? Each arrow is pointing at a clock face, which has numbers on it from 1 to 12. And each one of those hours is a destination.
And when there's no number, it means to the center of the...
Right to the center. Yeah. And of course it is an indication now for the middle circle and the inner circle.
It can include, but this one doesn't include, so we assume it's
This one, right, this one doesn't have that. Of course, you could decide.
Okay.
If you rewrite it, you can add numbers if you want.
Frey, the little black arrow in the second one is really confusing me.
Yes, so you remember this idea of a larger circle, a middle circle, and an inner circle. Okay, so when I put an arrow that's puncturing or denting, let's say, a circle, then it's that middle one.
Ah, so it's okay. It's pointing at the circle.
It's going towards the middle circle, somewhere on the middle circle.
Okay.
Yeah, not towards the other. Because without any circle at all, it's going right toward the middle of the all three cross, right? The dead center. But when I do this, then I'm going towards somewhere on that middle circle ring.
Okay.
If I were to do this, then it would be the little circle, somewhere on the little circle in the middle. So it's another way of saying you're going in a diagonal. But it's not telling you which diagonal.
But no, but it's on the center.
You're free to, you can make that.
Yes, but once it's like from here, is
You always,
The new version
because
is
we
not
always go like it's always this move
I'm making it.
in what we end up with
But the first one,
going towards the finger.
we did the
Yeah.
first inferior.
Like you never
What
put
is
it.
Oh,
That's
I wanted
cool.
to have it done.
Like,
so fine here.
But
Yeah, if you go like
Yeah.
yes, okay, it's always that.
I think it's
Yeah,
gonna be,
Okay, got it.
Oh, okay, this is this way.
I'm hoping.
Oh,
In the,
okay, so this, okay.
Yeah, like towards.
they're not going to be far away.
This is the fifth one.
Yeah,
We have one more.
so it's a spin like towards that.
And then the next one is.
Because we're,
Yeah, so I
like I said, we need to talk about things and try, practice, rewrite, and we come back and we discuss, and our perspective changes. And there's new information we missed, or mistakes that we made, and we correct.
I'm a bit confused now. Is it like this
I think it's better to get there. While you're trying that out. I mean, the sagittal is the rotation.
With the figure, yeah, the whole body.
And
Okay.
Counterclockwise spin.
Counterclockwise spin.
Yeah.
Which,
But where? On the right. Like, where is that?
what do you mean where?
Yeah.
When you put a number.
No, we just need to put it somewhere.
Which body part?
Yeah.
So,
No, but I don't like. It's the same.
No, because I haven't got a grasp of what.
No, me neither.
What
Me
is
neither.
it? Me neither.
No, don't worry.
yeah, we're figuring it out as we go.
Yeah.
So,
I think it's
so we're on the second one?
Yeah.
We're on the second one?
Yeah. So we're on the sagittal plane. No, the second one.
I don't have a meaning.
The one with the two arrows pointing to the right. Yeah.
So, we're talking about...
Yes. Oh, you mean like a video?
Give a.
Yeah, like a video of a sequence,
Since the end, what do you want to say?
this kind of
I
symbol.
think that's the.
With